Chapter 9 continued, Models of Chemical Bonding, Section 9.1, Atomic Properties and Chemical Bonds. This is figure 9.1, and it shows the periodic table divided into three types of elements: metals, nonmetals, and metalloids. Part B of this slide provides you with a summary of some of the important properties of metals, nonmetals, and metalloids. It is these properties that allow us to distinguish a metal from a nonmetal. Whenever two atoms or ions are strongly attracted to each other, we say there is a chemical bond between them. A chemical bond is defined as the force that holds two atoms together in a molecule or formula unit. There are three general types of chemical bonds that can form between atoms and are a result from the three ways two types of atoms can combine. The bond formed between a metal and a nonmetal is called an ionic bond and forms when there is a complete transfer of one or more electrons from the metal to the nonmetal. Ionic substances generally result from the interaction of metals on the far left side of the periodic table with nonmetals on the far right side, excluding the noble gases, which is group 8A. One or more electron transferred from the metal to the nonmetal will result in the formation of ions that have a noble gas configuration. The ions are held together by an electrostatic attraction between the cation and the anion. Ionic bonding will be discussed in section 9.2. A covalent bond forms when nonmetals share electrons. Most of this chapter and the next chapter will be devoted to describing and understanding covalent bonds. Metallic bonds are formed in metals such as copper, iron, and aluminum. Each atom in a metal is bonded to several neighboring atoms. In the simplest model of metallic bonding, all the metal atoms in a sample of a metal pull their valence electrons into an evenly distributed sea of electrons that hold the metal core together. Therefore, the bonding electrons are relatively free to move throughout the three-dimensional structure of the metal. Metallic bonds give rise to such metallic properties as high electrical conductivity and luster. We will briefly discuss metallic bonding at the end of this chapter. Figure 9.2 illustrates the three models of chemical bonding. Figure 9.2a illustrates the formation of an ionic compound with the transfer of an electron from the metal to the nonmetal. The attraction between oppositely charged ions is very strong, resulting in the formation of the ionic solid. Figure 9.2b illustrates the formation of a covalent compound through the sharing of valence electrons. The electron pair is localized between the two nuclei of the atoms engaged in the covalent bond. And finally, figure 9.c illustrates the formation of a metallic bond through the pooling of electrons. Figure 9.3 shows the gradations in bond type among the period 3 elements shown in black and the period 4 elements shown in red.